Thank you, everyone, for coming today. We are going to talk about an app named Gaia Pulse, which we have built at JP Morgan. And this app is the first step in our journey to try to solve the observability problem in our enterprise hybrid clouds. Okay. Let us first introduce ourselves. So I'm Lois Blanc. I'm Vice President at JP Morgan. I lead an engineering team in Singapore working on observability and telemetry. And this team belongs to the cloud team of JP Morgan.
My name is Yu Yang. I'm also from the Singapore platform service team. I'm currently working on the Gaia Pulse.
So a couple of disclaimers. All the opinions expressed here are only our own, and they do not represent the opinion of JP Morgan. And all the trademarks that may appear in the slides are belonging to their respective owner. And the mention here is for referential purposes. So the business at JP Morgan is sizable. We're talking about $23 trillion of assets under custody, 51 million active digital customers, 6 trillion payment processed daily. And to support the business competitiveness, the bank is investing heavily on technology as well. So some of the numbers reflect that effort, right? $11 billion invested in technology, 53,000 technologists in the bank, and more than 6,500 apps running on a daily basis. Gaia is our internal private cloud. So today we are talking about a product called Gaia Pulse, which belongs to the overall product, which is Gaia. So Gaia is based on multiple open source platforms and services, usually best in class and cutting edge, and it's really designed to maximize developer productivity. So Gaia was the first step into to drive our cloud first approach, and it's in prod since March 2017. So now let me give you a bit of context of the problem that we are solving today, right? Traditionally, when developers were building monoliths, the business logic, ref data, and front end were in a single node, and you had many of those single nodes. So it didn't mean that it was easy to understand the behavior of those applications, but it meant that the context of observability was consistent. You had nodes to look at them. Then people started to move to cloud-native design. So we exploded those monoliths into stateless microservice supported by stateful microservice. So it is a bit more complicated, and understand how this system will behave as a whole will bring more challenges. And then we move to a hybrid cloud construct, right? So instead of having developers owning every single of the node running those microservices and those stateful services, we move to managed service, managed platform, which may act as a black box. So it's getting increasingly difficult for developers to understand the behavior of their application. And they have to go and hit every single of those platform and services to try to understand what's going on. What are the metrics, what are the events, what are the logs, and so on. So Gaia Pulse tried to reverse this pattern and to say, from all the platform and service where developers are deploying their application, let's bring them back to them their telemetry data. So Gaia Pulse is a Cloud Foundry marketplace service which enables any cloud developer in the bank to have access to their app metrics, but also to the metrics of the platform and the service that their app is running from or depending upon. So how does it look like, right? Let's take a simple bank application. One microservice runs on Cloud Foundry, a couple of microservices run on Kubernetes, a third one is using an event stream, let's say Kafka as an example. The consumer of Gaia Pulse will be able to go to one of the Cloud Foundry marketplace, provision the service, and without any configuration, without anything to do, they will have a Grafana dashboard which show exactly what are the metrics for their apps, what are the metrics for the container underlying those apps, and if there's an event stream, for example, it could also display the number of pub sub per second on the topics that they consume. So the key aspect of the application, right? There's auto-discovery. If today the developer add a microservice to the app, the dashboard will reflect to that dynamically. It's opinionated. If you provide a service in one click, it has to come in a fully shaped way, so we have to make opinion for that. No, sorry. It's also designed to drive the behavior about building SLOs into the app and capturing those SLOs to have a more data-driven way to run application. Okay. So let's look a little bit about the high-level architecture of Gaia Pulse. And first, we'll look a bit about the environment, and then we'll drill down into the product itself. So what do we have on the screen, right? We have applications running on platforms, for example, Cloud Foundry, consuming services. The platform and services will have the responsibility to publish the metrics for the apps that they are consumed by. And on the consumption side, we have what we call DevOps, but basically it's application developer, DevOps. That it's all the same category, right? We belong to the culture where you build your app, you run your app in production, the same team. Pulse was built in a context that there's a very strong demand for telemetry, for metrics, for observability. So there's also the concept of wholesale consumers. Let's say the SRE belonging to a whole business unit. They don't look after one app, they look after hundreds of apps. And similarly, what we call the cloud SRE, so the SRE working on the Gaia Cloud, they look after the whole platform health and all the health of the apps running on the platform. Applications are exposing metrics to a metrics exporter. We'll talk a little bit about that later. Also, this architecture implies that we build a metric exporter for the platform as well. And we see an interesting concept, which is the metadata enrichment. So I don't know how many of you are reading multiple Cloud Foundry foundations, but those foundations live in isolation. And they do not necessarily carry the context of the business app, which may be distributed between multiple foundations. So this step is crucial to make sure that when we export metrics downstream, they contain all the metadata, which will enable us to give this metric to the right application developer. And same for the services here. In the middle, we have an aggregation and syndication layer. So this layer has multiple objectives, right? We do not want to expose the platform metrics exporter from the consumers directly, because this is part of the platform boundary, and this is sacred. We don't want to create load that is not controllable there. So this layer allows us to protect, in a way, the platform component from the consumption, but also to, as we build it in a federated way and integrated way, we can also use this layer to slice and dice the data differently, and we'll talk about it more later. Again, we talk about those source of reference data which enable to label the app, to label the metrics appropriately so they are distributed again to the right developer. Okay, and now we have our Gaia Pulse. So as you see, Gaia Pulse is a product designed for app dev and DevOps, which run one application. It's not designed to solve all the problems in the firm. As such, the exporter is able to export the metric for the application level straight away into Gaia Pulse. And Gaia Pulse will consume the regionally federated metrics component to get the metric of the app concerning the app. I think. On the wholesale side, and I won't cover this more today because it's out of scope for Gaia Pulse, they are actually benefiting from the fact that we are building this regionally federated integration layer, because they can get from this pass the whole telemetry for their whole business unit for this user, or for the whole cloud. So it's quite useful as well. So a bit more detail. It's a very similar slide to the previous one, except we took out the wholesale view, and we focus on the Gaia Pulse service. So on the left side, you still have application, platform, and services. The application exposes their metrics through various libraries. I mean, there's patterns using micrometer and so on. The platform uses what we call a platform Prometheus. So that component is basically a prom that we deploy for each instance. Each platform has its platform Prometheus, or rather, each platform instance has its platform instance Prometheus. And same for the services. The metrics are flying, again, to the integration layer, which is using the Federated Prometheus as a construct, and which allows us to aggregate the data and scaling horizontally. On the service side, we are, again, this is a single service instance, right? So a service instance is composed of one prom and one Grafana, which will have all the metrics for a single application. This is the control plane that provisions those service instances. So we use the Open Service Broker API, which enables us to expose the service through all the marketplaces that we have in the firm in a very simple way. The control plane needs also to be cognizant about the firm-wide reference data, right? It's the same story that we had earlier. If a developer add a microservice to its app, we need to update the configuration of the Prom and Grafana instances. And finally, here in this block, we have a service instance registry, I would say, which keeps the configuration of each service and is using on a NoSQL view. So this pattern also allows us to bring to the party the existing application living on virtual machine, right, which are not part of the cloud universe, not part of Gaia. They typically have agents which collect the metrics, and they typically have a custom service or a custom aggregation point. We can ingest those metrics back to the aggregation layer here. So which means that when the developers will provision the Pulse instance, he will have access to also, if it's the same app, and this app has some component running on virtual machine, it will also see the metrics of those components. I will give the mic to my colleague Guillaume to talk a bit more about how this is deployed.
Okay, so for deployment, at the moment we are deploying Gaia Pulse into 4 Cloud Foundry foundations. And the service instance of Gaia Pulse is also hosted in the same foundations. So you can see here in the the big box here, these are the production foundations where we hold Gaia Pulse. As a platform service, we are servicing the user from different environments, including development and test and production environments. So to limit the potential impact of any issue or production failure, we provided the independent service broker for each of the user environment. So when user try to provision a new Gaia Pulse service instance from a dev environment, they will go to the marketplace of a dev foundation, and the request will go to the dedicated service broker for dev environment. And the service instance will be created in the corresponding foundation. For each of the service instances created, we also keep a registration in global service instance registry. This is implemented in Cassandra, having 9 nodes deployed across 3 different regions for resiliency purpose. Also for user to access the whole list of Gaia Pulse service instance that he has acquired from different environments and for different applications that he owns. We have a portal, which is a web portal that will give easy access for user to see the list of Gaia Pulse that he has. So this tiered deployment model, where we have independent broker instance for different user environment, also enables us to run a promotional release process. So when a new version of Gaia Pulse is available, we will first release into production, but only make it available for the development users. After it being running for stable, then we will promote it next to the test level to make it available to the test user. And then after that, again, make it to the production level. So as of now, the Gaia Pulse is available for dev and the test users. And next, we'll make it available to production user. This is for the first release. So architecture-wise, as has been presented in the previous architecture diagram, we are relying on a global federated Prometheus to aggregate all the metrics from different platforms as well as services. And then from there, we collect the metrics into Gaia Pulse. However, there are 2 things that we need to enhance. One is we are hosting on Cloud Foundry, but we need to persist the telemetry data offline for long term. The other thing is, as we keep having more and more platform instance or service instance, the capacity requirement on the federated Prometheus will get bigger and bigger, and the scalability will become a problem. So to solve these 2 issues, we will move on to use Thanos, which is another product that built around Prometheus. It built a few extra components around Prometheus to realize these functionalities. One thing it does is to have separated sidecar that runs beside the Prometheus and keep copying the metric data generated by Prometheus into the offline object storage, off-platform object storage. And then when client try to get the data back, they will need to go through the query server, and which will attach to each of the store server. And the store server will try to get the metrics both from the Prometheus instance as well as from the off-platform object storage. And then it will merge the results and send back to the query and then send back to the client. So this will solve the metric persistence problem. For the horizontal scalability, the Thanos query server is a stateless query server. It can be attached to multiple Prometheus instances and merge the results and remove duplicates. So because of this capability, we don't really have to merge all the metrics into the same federated Prometheus. We can have multiple instances running at the same time and attach the Thanos query server to each of these Prometheus instances. That will solve the scalability issue. So the other benefit of the Thanos project is the query server API. Query API is compatible with the Prometheus query API. So the transition from the left side to extension on the right side will be smooth. So some of the challenges that we are facing so far. One is for application, we auto-discover the metrics it uses, it consumes on the services instance and platform instances. So each application can be microservice-based, and it can consume many service and platforms. The metrics on each of these service and metrics and platforms can add up to a lot. On the other hand, the application developers for business units, They are focusing on their own business logic rather than want to spend time on building dashboards, setting up query, running their own monitoring service. So it is preferred that they are given a pre-built dashboard. So one of the challenges here is how to give a pre-built dashboard without throwing all the metrics to the user and overwhelming them. The other challenge is sometimes the applications, they are both microserviced and they have a complicated topology architecture, and some of their components could be interconnecting with each other. So we need a bit more area to explore there to how to auto-discover the interconnection between the microservice instance across different applications so that we can auto-detect the metrics and present to the developers. So the key learning so far we have is to make automated holistic view of telemetry to the user, we need to integrate both north and south, as in from the application layer to service layer and platform layer. And also need to integrate west and east. So we need to integrate with cross-platform and across different service. So that has been pretty well solved by the Prometheus architecture, where we can build a federated architecture to collect data from different Prom instance that is owned by individual service and platforms. And on top of that, with the integration of Xenos, we will have the ability to slice and dice the data before presenting to the user for a holistic view. So I'll pass back to Luis to talk about the future plan for a Gaia Pulse. Thanks.
So as mentioned in the beginning of this chat, right, it's the first step. We don't pretend we are done yet with telemetry and observability in Gaia. So the first challenge is to integrate new telemetry sources. There are dozens and dozens of services in our ecosystem. We need to find a way to industrialize the work that we have done with the first set of services to make it fast and painless for the new sources to come in. And then it touched back to the challenge that we discussed for services, where it's not just taking all the metrics from a potential service which has 2,000 metrics, but also finding out what is useful for our application developer. The same concept applies also to other telemetry. So we are focusing now on metrics because there's a lot of demand for that, but we know, and we're having those conversations already, that events can be as important. So the underlying architecture will likely be totally different for how to bring events back to application developer for their application across the estate. But the contract should be the same. In one click, they provision an instance which will give them all the events pertaining to their infra and their app. And then logs and traces are with the same story. And that was, I told that part of the story. So how to bring metrics, events, logs, and traces into our Gaia Pulse, which is a single pane of glass for telemetry at Gaia. That's it for today, so we can take questions. I think you guys have to go to that microphone there to ask a question. No question? Okay. Thank you.